Okay, so today we have something a little different. This is probably the first piece of test equipment that I've done on here for someone. This was dropped off with me shortly before I moved. I'll have to get it back to the customer here fairly quickly. This is a precision branded tube tester. So take a look inside here. I do like these earlier ones, and this one has seen some abuse over the years. The cabinet's in pretty poor shape. Almost all of the veneer in it is warped to some degree. It's hard to see. I don't have the lid in view. If we pan up here, we can see that there's, well, you just have to take my word for it. There's a lot of bubbling. It's either humidity or something has kind of screwed it up. Anyway, back down to the actual unit. There are really two main kinds. Well, there's actually three different kinds of tube testers. There's the really basic ones, which are really just short testers. I have one actually that comes in a little plastic case about the size of a slice of bread, and all it does is make sure that there are no inter-electrode shorts. It has a neon lamp that glows if one of them is shorting or something. Very, very basic, not super useful. Most people want to know if a tube is good or bad, and not purely in the sense of whether it has filament continuity. So the next best thing would be one of these guys. And I guess the best way to describe this would be that it is an emission tester, in that you're basically looking to see how good the cathode material in the tube still is, or in the case of directly heated tubes, how good the filament is. So you're comparing. You have this lovely little scroll wheel right here, and I don't know if I can get closer in on that or not, but this is actually a piece of paper that's wound up between two reels that has, at the far left you have the different tube types that it's capable of doing, and depending on how old it is, it may or may not include some of the older ones or some of the newer ones. And then it has what you're supposed to set each of the various controls for. So you have things like A and B are usually along the lines of which pins does it use for the filament 2 and 7, or rectifiers tend to use something different. What filament voltage you're going to use, your bias, your plate voltage, and then some other miscellaneous controls. I suppose if there's like a screen grid or something, there's usually an extra wire that comes up out of the back so you can clip it to a grid cap. And then you have all the various push buttons on here for running different tests. And unfortunately, I don't have any of the documentation to actually tell me which buttons are perform which test for which tube. There is some old papers that came with it up here where the cord is stashed that do show some of the tubes, but I really got to try and find a manual or a reference on this thing to actually figure out how you're supposed to check a tube. And so you can see we have the dial, the meter up here. Then we have two basic sections, replace and good. And this is basically saying if you have a weak emission, you're not getting a lot of electrons flowing off the cathode to the plate, you're going to be over here. If, however, you have good emissions, you get a lot of electrons being flung off from the cathode material, you're going to be in the good section. That's basically it for this style of tester, and that's usually good enough for most people. If you just want to see if a tube is usable, if it's not completely dead, this is one way to do that, and then the other way is to just stick it in a radio and make sure it works. The guys that do audio tubes, however, generally want what's called a transconductance tester. Now I have one of those. I believe it's a TV10, so one of the big military suckers. I'll probably show it off in a later video. But they actually test for mutual conductance, which honestly I can't describe. I need to read up a bit more on it. It has to do with its amplification factor, or it's measured in micromhos. It's the opposite of resistance. It's like it's like admittance. Anyway, not going to get into that. Right now we're just looking at trying to make this thing functional, and if possible, I might try to do some cabinet work on it. The top and bottom are veneered. I'm not sure what they're veneered in. It's a fairly tight grain wood. I thought it might have been walnut, but honestly I'm not sure. It probably is. The inside's not so bad, but I thought, maybe if I could reskin the top and bottom, it might not look quite so bad, and then maybe give it a new lacquer finish. But I can't really do anything about the inside of this thing. This was probably silk screened, and it's a bit rusty, so I really don't know if it's even worth it to clean up the outside if the inside's never going to be able to look as good. But it has had some modifications. Someone included some pin straighteners for tubes up here for the miniature types. Someone's posted some little labels on here about battery tests. I guess you can use this thing as a voltmeter, or if that's just someone's notes. It's had an extra socket installed here, probably so that you could plug in the set that you're testing the tubes in or something else into the same line socket. It's kind of odd to see that. And the short indicator neon tube apparently went bad, and instead of simply finding an equivalent bulb, they just soldered in a regular old neon lamp, which that'll work. But the original would have been a bayonet. I'm afraid this is a bayonet or a screw-based bulb. It's a screw base. I forget what any type bulb that would have been. What's also neat about this little guy is we have this extra pair of pin jacks from here labeled noise test, so you could actually check the tube for microphonics. You plug in a high impedance headset, which I actually have one, and the only capacitor in this entire thing is to couple this to prevent the high voltage DC from getting through and to pass the audio signal, if there is one. And that's really it. This thing is almost entirely nothing but switches and rheostats that'll need to be cleaned. It has an 80 rectifier tube in there, which is still good, but I need to re-glue the base on it. It's a little bit loose in its socket. And there are a bank of resistors that I should double check on one of these controls here. I think it was for the plate supply. They're fairly large. And yeah, that's really about it. This is a very basic meter. All you're looking at effectively is how much current is flowing from plate between the cathode and plate. That's about it. That's your basis for whether or not the tube is good. But unfortunately, in my attempts to make it work, I still don't have any clue how to use any of these controls. It didn't come with an instruction manual, so I think I'm going to look that up on the internet now and see what else I can find about this. So I've got good news and bad news on the tube tester. The good news is that it does actually work the way it's supposed to. I tested a few tubes out in my garage with it, and it seems to be working fine. Got the one capacitor replaced, resistors are good. Going to fit a new line cord to it and deal with that. The bad news is, after looking at the cabinet further, I determined that the top and bottom were both way too far gone to just reskin them with new veneer. The way they were put together was effectively a layer of veneer on the inside, then a middle layer of a thicker material, probably like thin plywood, and then an additional layer of veneer over the top of that, and they did that in top and bottom. Of course, after being exposed to lots and lots of water, it's all delaminated. So it all came apart. There were already chunks and strips of it missing, so I basically just tore the top and bottom clean off the thing, got rid of them. There was no way to save it, and if I had put new veneer over it, the surface wouldn't have been near flat enough or strong enough to hold it. It was bad. So, which brings me to my next point. This is currently what I have for the cabinet. Yeah, it's a puzzle right now. Thankfully, it's all a fairly easy to put together puzzle. The grooves, all the little fingers in here are still good, and I've been working on removing the old finish from all the pieces. There's a lot of discoloration in places from where the hinges were, and a lot of the surface is irregular, so I've done a lot of light sanding, trying to get them clean in and out so that I can reassemble it. And what's interesting is they didn't really use any nails in this. I mean, they used nails to put these pieces on the inside where the the tester edge actually sits in there and screws into. Those are nailed into it. But the sides, the way the box is formed together, when these pieces actually lock into each other, there's no glue at that joint. There's nothing there. They are, however, glued on the underside to the bottom veneer, and then they're glued on the top half to the upper veneer. And that's really about it. It's not quite as strong as I would have guessed it would have been. So when my plan is, since I have all the pieces to make the top and the bottom, and I've still got a little more cleaning work to do to get those all ready. So we have all the pieces for the top here, we have all the pieces for the bottom here, and the bottom's almost totally good except for this one section here that had been severely warped. And this is actually the opposite direction of where it was warped originally. Originally it had a severe bow out and it was actually pulling away. I tried soaking in the whole thing in water and then clamping it flat and letting it dry, but I didn't have my clamps properly placed, and I just wound up changing the direction of the bend. So I'm going to have to do that again, soak the wood fibers, properly clamp both edges nice and flat against a piece of material, and then let it dry out again, which I know that this works now, so that's a decent strategy. And then once that's done, I'll finish stripping this, giving everything a light sanding, and then for the top and bottom, instead of going through all the trouble of doing that 3-layer sandwich that was originally produced for it, I just went to Home Depot and picked up a sheet of, I think it's like a 2x4 foot sheet of 5mm underlayment. I don't actually know what species of wood is. I could have gotten something like birch, but the birch is more expensive. It's basically just a ply, but the outside is nice and smooth. It's got a decent looking grain pattern on it. I mean, the top and bottoms of these, they were nothing fancy. They weren't like really nice figured walnut or anything. It was just, in fact, it might have been the same species as the sides, just a really thin slice. So I'm going to use a solid piece of material for the top and bottom so that it has plenty of rigidity, and not only will it be glued to the top and bottom, I'm also planning on using small brad nails to affix it to the undersides of all this so that it won't have a chance of separating. And then once it's all put together, I'll probably do a lacquer finish on it. That's most likely would have this originally had colored lacquer on it. I don't know if I'll go quite that crazy with it considering the overall shape. I might just give it a light stain and then lacquer it, and because it's mostly going to be a display piece, but the customer might actually use it to test some tubes. So that's where we are on that. The next step, like I said, is going to be for me to fix this one thing, and I think I'll go ahead, finish cleaning the pieces for the top, and once these are all clean, I'll assemble them into their little rectangle and see about getting the top section cut for it. And, I need to check on the hardware. I have been soaking all the hinges and screws in rust remover, so made a decent amount of progress on this at least. Right, so after getting all the pieces sanded and cleaned up, I then started to glue the frame assemblies back together to make them a little more rigid. So this is actually the top here being reassembled. And then a piece of Luan wood was cut and shaped and sanded and then clamped to the top of that section. Got both sides. That's actually the bottom there. So same procedure for both. Pretty simple. A lot of clamping force on the edges. And then, of course, the finished product was pretty easy. From that point, it was just finish sanding around the edges. So after all the gluing and reattachment and all that good stuff, here we have the two sections with their brand new Luan wood top and bottom. So take the lid off of here. I've got most of the hardware taken out of the acid bath to get all the gunk off of them. I'm pretty happy with the way this turned out. I had to do a bit of sanding to try and level a few things out. The warping on the outside pieces of it was somewhat bad in places, and it was causing it to move outward. So I tried clamping it and gluing it, and it helped quite a bit, but it isn't perfect. This is mostly just to make it strong, not really to make it, you know, brand new. There's no real good way to do that unless you want to sand down a bunch of oxidized outer layers of wood, and I just don't have the time for that. I wouldn't be left with much anyway. Plus, there's all this stuff on the front here. You can see it's been pretty gouged up. The original handle was long gone, so someone simply screwed on another one that they had laying around, maybe from a piece of luggage or something, and they didn't really do it straight. That's a little unfortunate, but it's the only handle I have to work with, so it'll go back on there. And if I look at the bottom on this guy, I've already done the rough finishing, so I used a 120 grit orbital sander to get the edges flushed up, and then I use 80 grit on my orbital sander to get these flushed up, and then the 120 to gently bevel the edges here so they're not so rough. Now the next thing I'm going to do is use some hardening wood filler, and there's a few areas in here that have air gaps or just some little spots that aren't solid, or like a spot where one of the fingers might have broken off. And I'm going to go through, fill those, smooth them over, and then do some final finish sanding with just a normal piece of sandpaper, and do it by hand to get a feel for the curvature of everything. And then once that is taken care of, the last step will be to go through my stains and stuff and find something that will give the loin wood a relatively nice color. I was thinking, American Golden Oak or something. Might be a bit too light for it. Some areas of this wood are fairly dark. I was considering using a walnut color and trying it out on all the wood to see how it would do, but I'm going to take a scrap piece of loin wood and try that first, just to make sure it comes out okay. And then, if that goes well, I also have some toners. Not very new ones, but I do have some perfect brown and I think some medium walnut left over if I have to do a little bit of matching. It's not going to be, you know, amazing looking, but it will be solid enough that you can, it won't fall apart when you want to use it, because the top and bottom on this were just so crunchy. When I removed them, they just came apart in pieces. It was a mess. So that's where we are with this. And the next bit, hopefully, I will have the finishing going along. Hopefully add some photos in of that process too. So after about 2 weeks worth of effort here, the cabinet, or the case for the tube tester, is finally all back together. Just the cabinet though. I don't actually have the tester reinstalled. I've got to solder in the new power cord and the grid cap lead before it's all done and dusted. And also the hardware that actually screws the tester in place, I've gotten in the deoxidation bath. But all the rest of the hardware has been reinstalled, and I picked up some new screws to replace a few things that were missing. And more importantly, I got all new rubber feet for that, and that was quite a challenge. But I suppose I should just go ahead and flip it open. We can see the overall finish there. So I did some Google searches later on, and I realized that the original finish on these was extremely blonde. Most of the ones I've seen had practically no evidence of ever being toner lacquered or anything like that. However, in the case of this one, it was, well, a lot of it was so badly discolored that doing a dark walnut toner on it, in addition to the special walnut stain, kind of helps even out the general crappiness of some of the areas, and not to mention the bowing on the sides. It isn't straight. It isn't perfectly straight, as much as I'd love it to be. That being said, the finish did turn out pretty darn nice. Hard to see on camera, honestly. I went with, let's see, I did a stain sanding sealer, sanded that. Then I did 2 thin coats of Bellin Dark Walnut toner over the whole thing inside and out. And I followed that up with 3 coats of gloss clear lacquer, did a wet sand on that, and then 3 coats of semi-gloss, because, you know, it's a piece of test equipment. It's not going to have a super high gloss finish, and it might get knocked around a little bit. All the hardware again got derusted, and I did all of these, gave them 3 coats of clear semi-gloss lacquer, back and front. And then what hardware was still good, I reused, but you can see I've got some new screws holding on the data plate and new screws holding on the handle. Now the handle is not original. It originally would have had a Bakelite one, and the holes for it were still there, but I'm not going to find one of those just lying around, so I just reused that. And then, if we rotate this around, I spent, let's see, today probably a good 3 hours driving around to every hardware store I could find looking for these little rubber feet. These particular ones have a small steel washer in the back of them molded in, and then I want to say either a number 4 or 5 hole, maybe a number 6. And yeah, because originally this had all 4 on the back. I removed all the non-original stuff, a little bump stop and the piece of clear plastic, lucite, whatever it was. Got rid of all of that because it just, I don't know, it looked bad. I plugged what holes I could remember to. This one, I did not, and that was dumb, but oh well. But I managed to get 8 more rubber feet, and at the very last hardware store, our local McClendon's had a drawer with 10 of them in it. And I just bought practically the whole drawer there. And they even had exact matching wood screws, like these. They don't have the same finish, obviously. You can't get them in the sort of blackened finish. You either get brass or steel, and then if you go for the number 4s, you can only get brass. But that didn't matter. I reused the original screws for these back ones. These were gone. In fact, the back ones and the bottom ones both sets were missing. So if we get it on its side here, see, I've got all those set up. So now we have all 4 brand new feet, and I figured that out through doing some more Google research, and also by digging the original bottom piece out of the garbage and looking at it, and sure enough, there were 4 holes evenly spaced inside the corners, and I used those dimensions to position these so that they're as tight inward to the corners so you can't get your fingers in there. These guys will never be able to access because the tester well, actually these 2 are covered by the tube tester. These are tucked in close enough so that if you're not dumb, you won't, stab yourself with them. And that basically covers that. But now, all we have to do, and I'm hoping that everything fits okay, is, hello Mr. Tibbles, is say hello to the, yeah, say hello to everybody. Anything else you want to add? Really? Mm-hmm. You have to forgive him, he's a baby. Mm-hmm. Can you help me on the tube tester? I've got to get this thing reassembled. There were 4 little rubber bumpers on the inside of the lid, and I get the feeling that those were probably stolen from the bottom, and they just kind of screwed them on the inside. I don't know what they were planning on doing with them, so I just took them out and didn't bother reusing them. The rubber was so hard, but the hardware, the screws were perfectly fine, so I reused those for the back. And then, of course, I've got the everything else is nice and clean. I do, however, like how the toner turned out on the inside. And that was the thing. On this cabinet, I looked at these on the inside, and I swear there was evidence of them using a toner lacquer of some kind, including inside the front here, because on the original, all the edges where the glue was are completely blonde, but the center on the inside here had a very obvious toned lacquer coating. It was fairly dark, so I just went off of that. Now, I didn't really hit up the inside of this here, with the toner lacquer simply because I didn't find it necessary for a part that you're not going to see. But I did make sure to get the rest of this, and all this was sanded and done. It's not perfectly smooth, but it's good enough for a piece of test equipment, I think. And at the end of the day, it works, and I'm happy for that. I will do a quick demonstration of the tube tester once I get it reinstalled. It's actually pretty straightforward. But yeah, I'm super happy with the way this turned out, and I do hope the customer is as well. Okay, so we're back with the tester here, and as you can see, I've got it put back in the cabinet, although not entirely permanently. The screws that hold it in place are still in their cleaning bath, and I'll take them out later today and put them in here to get this sealed up. But I did take the time to install the new power cord and to reattach and clean up the grid cap lead, which is very important. Can't test a lot of tubes without that. And that's the point of this segment. I'm going to do a little quick test on one of my random tubes here, just to give you an idea of how one of these actually works. So at the bottom, we've got this wonderful scroll chart here, and I know it's hard to see, but the basic idea is at the far left you have the tube type, and there's two sections here, so obviously if you don't find it on the left roll, check the right roll top to bottom, you'll probably find your tube, unless it's something extremely obscure or, I don't know, European. And then the next section will simply tell you, what section it is you're testing, because some tubes are, they'll have multiple sections, like say the 6A8 is a pentagrid converter that has both I want to say the 6J8 has a separate triode oscillator section, and then I want to say either a tetrode or a pentode main section for the actual mixer, and you can separately test those sections to see if they're working because they have separate anodes or plates. And the remainder of these, the A, B, C, D, E, and F, and the depressed section, these are all your initial settings. So all these knobs here, you have A, B, C, D, E, and F. When you find your tube, so in my case we're testing a 6K7 GT, so we just go to 6K7 there because the last two letters, the suffix letters on any of these tubes like GT or G simply denote the envelope type of the tube. So if you have a 6K7G, that's going to be the glass type, which has the shouldered Coke bottle appearance. Then you have the GT, which is glass tubular, which is this much simplified shape, which is much more common on later stuff. And then if it doesn't have a suffix, it was either made... It never had a metal octal variety when it was introduced, or it is an original metal octal. Those tubes will not have a suffix. So anyway, I've already got this thing set up for the 6K7 as these say. So A is set to position 7, B to 6, and so on for all of these. And now all we need to do is hit the tube merit button to turn the set on, but only to press it lightly. This is a two-position switch. So we'll just lightly click it until our light comes on, our meter goes to the middle, and you'll see there's a little line thing right here. This reset, the power light, it says line adjustment, is setting up for... This is so that if you go to an area that may be still running on 110, whereas another area might be running on 120 or 125, you can adjust the tube's the input power, the input voltage effectively, so that everything still tests the same. Otherwise you might put too much or too little filament voltage on a tube, or plate voltage, or whatever. Makes it hard to test. So when you start off, you want to make sure that the needle here is lined up with that little segment that says line. So I've already tweaked it a little bit to make sure that it actually lines up on there. We've got all of our knobs set to where we want them, so now all we got to do is stick our 6K7 in the octal socket up here, and the needle will dip a little bit, but if the tube filament is good and actually glows, it should return to normal. I tried a 6BQ6 on it a little earlier, and the filament had continuity, but it was so gassy that it just caused a massive draw, because it wasn't actually glowing, it was trying to burn up. So that is already glowing, which... It's hard to see on camera. It's a very dim orange glow, but I can see it, so I promise you it's there. And then of course we need to attach our grid cap, and this has got two sides, one for the later stuff with the small grid cap, and a big one for the earlier types, like the UI based tubes, like say a 224 or similar. And we're just going to stick that on there because that is our control grid input, and that's important. Maybe not so much on this guy because I'm pretty sure it just sets up a bias instead of actually applying a signal. And the next thing we need to do while that is warming up is do a short test. So all of these buttons right here are there effectively to make sure that there are no inter-electrode shorts. So we have our little neon lamp short indicator here. I couldn't get an original replacement for that, so I just left that one in there because it works, and you know, it's not going to be perfect. So let's double check and make sure we don't have any shorts. Now if it glows briefly, that's totally fine, but if it stays on, that means we got a problem. So nothing. Got a bit of a flash there, but that's okay. Flash there. And yeah, that looks pretty good. And then lightly click one of these to reset them all. So you usually want to let the tube sit for a little bit, maybe a minute or so that the cathode gets nice and warm. But I've already had this one on here because I know it works. And the next thing we're going to go ahead and do is fully depress the tube merit button until it locks in place, and we see the meter drops all the way down to 0. And now at the last section of the roll, it says depress. This is the tube buttons, or however many it wants you to push on this set right here to actually test the tube. And you'll want to press them one after the other. I tried pressing them in unison and it just pops the tube merit button back out. So for the 6K7 it says we want to press B and C to do a tube test. So it's punch in B, punch in C, they're locked in, tube merit's still good. And then all you have to do is hit the read meter button. And alright, so we are reading into the good section. And sometimes if you hold it there you can see a tube wobble up and down, or it might increase or decrease a little bit, but we're not going to push our luck or anything. And that's really all there is to it. And then once you're done, just hit the off switch and it resets everything. Pretty simple. We'll wiggle our grid cap off here and extract our tube. But the one drawback of this thing is that, well, it does show if your filaments are good, which is really all you'd want to use something like this for, and if you've got cathode emissions, which is also handy. This style of tube tester isn't really optimal for doing things like making sure a tube would work as a good amplifier. This tube effectively tests everything on it as a diode. Does it pass current? Yes, great. That's basically it. And the reason for that is because with these, they don't actually apply a signal to the grid. The good ones, the mutual conductance testers, are actually testing to see if you have gain. The tube will have, you know, like a certain limit that, like a certain amplification factor, like the beta value in a transistor, that you're supposed to get for that tube. And some have fixed mutual conductance values, and some have alterable mutual conductance values. They're called multi-mu tubes. And you want to make sure that, like, if you're going to use, I don't know, a 12 AU7 as a preamp in something, you want to make sure it's going to that tube, the one you're using that maybe new old stock, has enough mutual conductance, has enough amplification to actually get the output signal you want for a given input signal. And that's incredibly important when you're doing matching. If you have a push-pull output stage in an amplifier, you want to make sure your two output tubes have the same mutual conductance so that they will evenly reproduce the audio waveform that you're giving them. If one has a lower mutual conductance than the other, when one conducts and the other is not, it'll get a nice strong amplification, and then when the low one starts to conduct, the output will be nowhere near as high. So you really want to balance them. Most people will just take two tubes, like two 6F6s in a radio, and just jam them in there if they look to be the same type. And you can usually get away with that, but some people are pretty big sticklers for making sure that both tubes are, you know, closely matched. So you might actually see some people that do stupid things like matching 6K7s or matching, you know, radio tubes designed for, I don't know, IF amplification or dumb crap like that. I mean, if you're going to use them in an audio amplifier, maybe that's important, but for a radio, if you're looking on eBay and buying tubes, you don't need to go on there and buy a matched pair of 6A8s or something It's just people matching tubes because they can, and they know they're going to get some sucker to buy them, or they have no clue what the hell the tube is. But enough about that. I'm going to get this thing all nice and buttoned up, and then that's going to be basically it. I will be back shortly with the finished product here, and then it'll be off to the customer again. The last of the hardware has been cleaned and reinstalled. Everything's nice and snug in there. Cord is all coiled up. And to top everything off, we have the lid here with these split hinges. And there we go. All buttoned up and ready to go back to the customer. I'm pretty happy overall with the way this turned out. It would have been nice if the original handle was still there, except for this kind of nasty leather thing, but it's all I got to work with. I managed to get all the rest of it cleaned up well enough, all the new rubber feet and everything, so I think they'll like it. I thought it was a neat little project. I haven't done woodworking or anything in a while, so this has at least given me some motivation to do some more cabinet refinishing on some of my own stuff. The Airline movie dial set that I'm working on at the moment. I've got half the cabinet cleaned, and one more half to get to have the finish removed, so I can get to work on re-lacquering that. But for now, this will probably be the last thing I'm working on for a customer for quite some time, until I'm relocated in a new area and I drive around a little bit. Might put an ad out or something, but right now I'm looking for full-time work, so I'll actually be able to work on my own equipment rather than other people's for once. That'll be nice. But until then, thank you for watching, and I'll have more cool stuff coming up in the future.